radiation worksheet. So we know half-life is the time taken for the activity of a substance to halve. Radioactivity is measured in becquerel. Beta decay is the loss of an electron. How does that happen? A neutron splits into a proton and an electron. Alpha particle is helium atom. Beta particle is an electron. Gamma radiation is an electromagnetic radiation. Alpha particles are absorbed or stopped by paper. Beta particles are absorbed by aluminium sheets, and gamma rays are absorbed by a thick sheet of lead. So if you put lead there, nothing should get through. If you put aluminium there, gamma should get through, alpha should be stopped along with beta, and if you put paper there, only alpha will be stopped. Fission is when you split up a nucleus. Fusion is when you join two nuclei. Irradiation is when food or something is exposed to radiation to sterilize it. Right, let's carry on. Right, here we are. What is meant by background radiation? Right, so radiation that is always present in the environment. Right, that's what background radiation is. And where does it come from? It comes from the sun, it comes from rocks, it comes from radon gas. Okay, and comes, yep, that's enough. It's only two markers. So radiation, so let me get this right down. That is present in the environment, and it's always present. Right, you've got the activity of radon-22. What is meant by half-life? So let's just discuss this idea because this comes up a lot as well. So look, you had 1200, half of 1200 is 600. Go across there. I read that off. 3.7 days. 3.7 days is the half-life. What is meant by half-life, right? What did we say at the beginning? Did we say at the beginning? Yes, we did. It's the time taken for half the activity or radio activity it's time taken for that. Let's get rid of this word here. For the radioactivity to halve. It's time taken for the radioactivity to halve. That's better. Or for half the radioactive nuclei to decay. But let's stick to this. The time taken for the radioactivity to halve. Let's move on. Use the graph to determine the half-life. So we've just figured that out, haven't we? We picked a sensible point, 1200. We halved it, we went to 600. Then we went across to the graph, to the curve. Went down and read it, so it's 3.7. Oh, right, they don't like 3.56. Can't read. 3.8. 3.8. 3.8. So you've got to be careful with this, actually. That you read it off accurately. I read it off in a very casual way. I would have lost a mark there. 3.8. And what happens is you'll get 1 mark if you use these lines, because that's showing the evidence that you used the graph to try to read it off. You might have misread it, but at least you tried. If you just casually read it and put it down and it's wrong, you lose both the marks. Right, radon 2022 is formed by alpha decay. What did we say alpha particle is? It's a helium nucleus, isn't it? So it's 4, 2. Right, complete the nuclear equation. So we've got 234, 222. So we've got add 12 and 2. So that's 6, 92. We need 92. We've got 6. We need something else. Get 86. 86. Done. Radon also emits alpha radiation. Explain the hazards for breathing in radon 22. Right. Radon 222. Radon 22 can be breathed into the lungs inside the body. Alpha particles are ionizing and can cause cancer. Because you can breathe it in and it's highly ionizing, it can cause damage to your lungs and cause cancer. That's it. 7 minutes. Okay, let's keep going. A scientist wants to determine the half-life. Scientists measure the count rate. Stay out the science correct for the background rate. Right, we can just subtract it. Simple. Yeah, we can simply, it's a 1 marker, so you would subtract the background rate from the scientist's count rate. That's it, done. Right, here you've got activity, kilobecquerel and minutes. What is meant by half-life? What did we say? What did we say? Half-life is the time taken for the radioactivity to halve. Right, what did we do with the others? We picked this point, it's a sensible point, 50. Half of 50 is nice there, and I misread that last time, so I'm going to be careful. So that's 3, so that has to be 2.6. 2.6 minutes. Put your lines in, so if you do misread it, you lose only 1 mark. Bismuth. Okay, yeah, we can do this one. It's going to be quick and we can throw it in. Good. Bismuth 207 is a gamma emitter. Gamma is electromagnetic radiation. It's a wave. It's presented by the symbol 20783. How many neutrons are there in the nucleus of? You do 207 take away 83. You get 207. 207 is 124. It's that one. Which of these gives the best description of gamma? We said it is it's not an electron, it's not a nucleus, subatomic particle, no. It has no mass and no charge. So gamma has no mass, no charge. Right, a technician uses this method to investigate the penetration power of gamma. Place an existing source, measure the count for a minute, place a thin sheet of lead, measure the new count for a minute, increase the number of lead sheets, repeat the process. The table gives some variables for the technician's method. Complete the table to show whether each variable is dependent, independent, or control. Whoa. Count measured using that is a dependent. Distance between the source and the detector, that has to be controlled and kept constant. Number of lead sheets is the independent variable because you're controlling that. You're in charge of that. Time period is a control. Yeah, you have to keep them constant. Yeah. Do you know eventually when you do loads of these you'll get used to it, but you have to keep practicing them. You'll need this for bio. Mainly for bio. I've not seen this sort of stuff in chemistry. Well, there is actually. I lie. No, there is. So you've got to know dependent, independent, control. Right, we can do the. No, we'll call it quit here. Right, it's getting silly now. It's 10 minutes, 12 minutes. Okay, cool.